question 10 is on bias and MSE. I mean, I did eight examples on bias and MSE during the lecture, so you shouldn't have too much trouble doing question 10. Right. Please try and do this. Give you like a couple of minutes and see if you can do it. You guys done number 10? I mean, I did 8 examples on this during the lectures, so you shouldn't have too much trouble doing this. Anyway, if you haven't done it, let me show you how to do it. So this is okay. The first thing you need to do is to find the bias. Okay. So the bias of, can you see this? You see my right? Bias of P hat, which is the expectation of P hat minus the parameter that you are trying to estimate. Okay, which is the expectation of x bar plus 1 divided by n plus 2 minus the parameter. Okay, x bar is the sample mean. So this you can write as follows. Okay, x bar. Now this is like this. Are you with me so far? Yeah. Alright, now I'm going to take the expectation inside, so this becomes 1 over n times the sum of the expectations. Now I'm sure all of you know that the expectation of a binomial variable is what? N times p, right? So this would be 1 over n times p yeah. Now what you're summing here is a constant, so you have the sum of a constant is n times the constant, so n times this is n squared p. Alright, and this is clearly not equal to 0. So the conclusion that you have is that P hat is a P hat is a biased estimator of P. Remember, a biased estimator is one where the bias is not equal to 0. If the bias is 0, then it's unbiased, right? However, the limit of the bias as n approaches infinity is, now what's the limit of this as n goes to infinity? Is p, right? And the limit of this is 0 minus p, which is 0. So the limit of the bias is 0, hence you can also say that P hat is asymptotically unbiased for P. Alright, remember the definition of asymptotic unbiasedness is one where the limit of the bias is 0 as n approaches infinity, which is the case here, right? Are you okay, guys? So any questions on this, guys? The second part of the same question is to find the variance. To find the variance, you just need to find. Are you guys okay with this? Any questions? I mean, if you have a question, you can ask me later, okay? But let me do the second part of question 10. which is to find the variance of P hat. Okay. Now the variance of P hat is going to be variance of x bar plus 1 divided by n plus 2. Now using the properties of variance, this you can write as right, because remember that adding a constant or adding or subtracting a constant does not change the variance. So this one does not matter. So the only thing you matters is the one you divide by. When you take it outside, it becomes a square, right? Okay. Now I'm going to take the variance inside one more time. Okay. Now I'm sure all of you know that the variance of a binomial variable is np times 1 minus p, right? Okay, so the summing this gives you n squared p 1 minus p, all right? And simplifying this, you get p 1 minus p divided by n plus 2 squared, which approaches 0 and approaches infinity. Okay, so hence since the bias is 0 and alright, since both the bias and the variance approach 0, we have the limit of the MSC is also 0. Do you follow? Do you follow this argument, guys? That's because of one of the properties I proved in the class, that the MSC is the sum of variance and the square of the bias. Okay? Do you remember or not? You already forgot. Okay, hence alright, so that, are you guys okay with this? Any questions? I did 8 other questions like this in class, so you shouldn't have too much trouble understanding. If you have, please ask me. Alright? Can you do question 9, please? Now, question 9. Yeah, it has a mistake. It should be n. It should be n, I said I had to it should be n. Yes. That's a mistake. So.
said, adding a constant does not change the variance. So it's like this. It's like if you have variance of x plus a constant, that's the same as the variance of x. So this is the property I have used in this line here. It's the same as this. Alright guys, can you do question 9 please? Question 9. This is question 9, if you don't have. Can you please sign the... Thank you. Can you all sign this, guys? You all sign? Anybody? Lee, did you sign? I did. Sorry. Thank you. Thank you. Anybody else who hasn't signed? So question 9 is also on bias and MSE. Okay, guys, could you please listen, please, if you haven't done it. So you need to ask. The question is to find k so that this estimate is unbiased for theta. So what you need to do is to find the bias. You need to find the bias of theta hat and see when that can be 0, right? Right? So this is k divided by n times the sum of the expectation of xi minus theta. Now, do you guys remember we have xi uniform 0 theta. So what's the expectation? I'm sure you know the formula for the expectation of a uniform AB is a plus b divided by 2. So if you apply that, it will be theta by 2. Okay? You follow me? Okay? So this is k divided by n times n theta by 2 minus theta. So this is k theta by 2 minus theta, which is 0 if and only if k equal to 2. So the value of k must be 2. Okay? You follow me? Hello, guys. Are you okay with this? Alright, the second part is to find the variance of theta hat. So you do the same thing as I did in the previous example. So let me take this away. To find the variance, so you want to find the variance of theta hat, which is the variance of 2 times x bar, right? Which is 4 times the variance of x bar. So this is 4 times the variance of okay, and this is 4 divided by n squared, because when you take the n outside it becomes a square, right? I'm sure you know that. Times the sum of the variance of xi. Now once again, the formula for the variance of a uniform AB is b minus 8 squared divided by 12, right? You remember that? It's in the handout I gave you on the first day of classes. So that will be theta squared divided by 12. Okay? So this is 4 divided by n squared times n theta squared divided by 12, which is equal to theta squared divided by 3n. Okay? So hence right, so that's the conclusion. Are you guys with this? Okay. Do you follow this? Any questions on this, guys? Your right side. If you have questions, let me know, guys. Otherwise, can you do question 8, please? 8. If this is not okay, can you ask?
guys okay with that?
All right, let me show you. If you haven't done it, let me show you how to do it. So it's the same procedure as we did in question 8. Sorry, question 9. So you have okay, you have sigma squared hat equal to k times the sum and you're just told that you have a random sample from a population with mean 0 and unknown variance sigma squared, and this is the estimator for sigma squared, and we want to find the k so that is unbiased. So what you need to do is the same thing. Try to find the bias and then the value for k. Okay, this is the bias. So all right. Now take the expectation inside, you get k times okay, now let me ask you, how can you find this? How can you find this, guys? Because you're only told that you have a random sample from a population with mean 0 and variance sigma squared. So to find it, you just need to do a little trick. You see why I'm doing this in a minute. You will see in a minute why I am doing this. You see what I've done? I have subtracted this term and added this term, so I haven't changed anything. All right. Now, what can you say about this, guys? This is what? This is the variance of xi, which is given to be equal to sigma squared. All right. And what can you say about this? This is mu, which is given to be equal to 0. All right. Expectation of xi is the population mean, and this is the population variance, right, which is sigma squared. Okay, so this becomes k sigma squared plus 0 minus sigma squared. All right, so this is kn sigma squared minus 0, and this is 0 if and only if k equals to 1 over n. All right, you guys follow this or not? It's not. Is it difficult? It's not. Yeah, is it? It's not really difficult, is it, guys? Yeah. All right. So that's the first part. The second part of the same question is the second part of 8 is as follows. Let me take this out. The second part is asking you what the distribution of this guy here is. This goes back to, you remember when I talked about the sampling distributions, I talked about two sampling distributions. One is the chi-squared, the other one is the t. So I'm going to use that here. You see what I've done here? I have divided by sigma squared and multiplied by sigma squared. I'm going to pull this outside. So this is going to be sigma squared by n multiplied by Now, if you read my notes, you should know something about this. Because now we are assuming xi are normal with zero mean and variance sigma squared. So what do you know about this? You've been reading my notes or no? This has something known as the chi-square distribution, and it's in my notes. See my either the handwritten notes or the printed notes. See my notes on if you look at my notes on the chi-square distribution, you will see that this has this distribution, right? Okay. All right. So the conclusion is the following. The conclusion is that sigma hat squared is equal to sigma squared n multiplied by cos squared n. Right. Okay, guys. Any questions on this? Can you do 7, please? 7, if you're okay with this. Can you do question 7, please? Alright, when you do question 7, can you please use this formula? Remember, I gave you two different formulas for the sample variance. Use this one, which is the unbiased version. This is the unbiased version of the sample variance. So use this one, okay, for doing question 7. Right. One is unbiased, another one is biased. This is the unbiased version of sample variance. question 7 also using the chi-square distribution, so you need to know the stuff I talked about on the chi-square to do question 7. Alright, let me do, I'm running out of time, so please let me do the first part of question 7. Okay? So this is question 7, part 1. The question is asking you for the probability that the sample variance, which is 1 over 10 minus 1, 10 is the sample size, sum from 1 to 10, so you're looking for this probability. Okay. Now the first thing I'm going to do is I'm going to multiply all across by 10 minus 1, which is 9. Okay, so this will be 9 times 25 less than Okay, the next thing I'm going to do is I'm going to divide all the terms here by this variance of the population, which is, remember, the variance of the normal distribution here is 36. And you see in a minute why I'm doing this. I've divided by 36, which is the population variance, the variance of the normal. Now, let me ask you one more time, just to refresh your memory on the chi-square distribution. What distribution does this have? Do you remember? Oh, you already forgot what we did. Come on, guys. This has the chi-square distribution with n minus 1 degree of freedom, which in this case is 10 minus 1. Once again, C either my printed notes or the written notes, either both of them contain this result. Alright. One of the properties I mentioned is that this has a chi-squared with n minus 1 degree of freedom. So this becomes 25 divided by 4 less than chi-squared 9 degree of freedom less than 15. Alright? Okay, and this you can compute. You can compute this. You can compute this probability using R. Okay? Is that clear, guys, or not? So you need to really, on top of the material to answer these questions of this kind. Okay? And part 2 is also using the same result. So to do part 2, you need to use the same result. Okay? Alright, guys, and the full solutions to all the problems are online on the course website. I'm sure you know. So if you want to check out, please do. Okay. All right, guys. I'll see you next week.
variance of this x. The mean you don't need to subtract mean. Because the result. You should. You just need to give, you should look at do you have the notes in first one? You should go through it. No, I'm good there. Oh, good there. Yeah. Sir, you have a question?
No, I just want to.
Huh?
I just want to take a picture of this question,
Okay.
this solution.
I will post it online so you can see on the course website all the scanned version of all this. Okay. Did you understand this or no?
No, I haven't listened, so I want to.
Did you get a quarter?
Yes.
Okay. Okay. Sorry. What's the question? Here. Not this one. No, not this one. There's another result I mentioned. Not this one. There's another result I mentioned in the class. I think you don't have it here. Maybe you. It's this one. Yeah, this one.
We did a minus.
Sorry.
Oh, yeah, I know.
This is yours. Yeah, this is yours.
Oh,
So you see, you have to divide by sigma squared to use this result. You have to divide both sides by sigma squared in order to show that this has a plus square and minus 1. Okay? Is that clear now? Okay, thank you. No, this is n. This is correct. There are two results here. This is one result, and another result is